Okay, what I've done is I've taken all that DT data, graphed it, and determined the acceleration, and I have plotted here the varying masses, 1.22 kilograms being the mass of an empty cart, and then 1 kilogram on the cart, 2 kilograms on the cart, and 3 kilograms on the cart. And I have identified the following accelerations. Now, here is a graph of our data. Well, we have been messing with quadratics so often that this certainly looks like a quadratic. So let's go ahead and fit a quadratic to this expression and see what we get. Well, here is a quadratic equation. Here is a quadratic equation, and you can see that our error is 0.02. So that's not too bad a fit, but let's go ahead and try a couple more fits to see if we can get a more simple mathematical model with a better error. Now, in this case, it's definitely not aligned, so I'm not going to bother doing that one. But what I am going to look at is looking at this curve right here, the way it's oriented. I do know that a higher power function could definitely model it better, but that means it's more complicated. So I'm going to try to stay away from those already. But just looking at the curve, I do know of one more curve that has exactly the shape that is more simple. And that curve is called an inverse curve. Now, an inverse curve is very simple and does have that shape, so I'm going to give this a shot. Now, I'm looking at the error here. I have 0.02 and 0.004. Well, I have definitely improved my error. I've gotten closer to 0 by a whole order of magnitude here. In addition, I have a much simpler graph that appears to model my data even better, more simply. So, I am going to stick with my inverse curve as the model. Now, what the inverse curve says is that if I increase my mass, which my mass is located on the x-axis and my acceleration is reflected on the y-axis, if I increase my mass, my acceleration decreases. Well, that should be in accordance to an inverse relationship. So let's take our data right here and take it to the board and physically interpret what we have.